Okay, so Junior Roberts here with realjuniorroberts.com. We're on to video 3 of our introduction to graphs in physics video series. I've done the previous videos, so we'll place a link to those videos in the description of this video, so you'll be able to check out those other videos. So let's get right into this video. So we'll start by looking at our learning objectives. Now, the learning objectives of this video will be to discuss the type of information that we can obtain from a graph, apply a formula to determine the gradient from a graph, and also discuss trends and relationship from a plotted graph. Okay, so let's go right into it. So we're going to start out by asking ourselves what can be obtained from a graph. Okay, so from a graph we can obtain a value on the y-axis that corresponds to a value on the x-axis and vice versa. So therefore, we also, in addition to obtaining a value on the y-axis that corresponds to a value on the x-axis, we can also find a value on the x-axis that corresponds to a value on the y-axis, right? And whenever we do this, we call this process extrapolating, right? So we will extrapolate different values, right? And we're going to actually be looking at how exactly we go about doing this in this video. Now, whenever we are extrapolating, we simply identify a value on either axis, so either the x or y, and while using a straight edge, we draw a line from that point on whichever axis we have chosen. So let us say we have chosen the y-axis, so we'll choose a value on the y-axis. We'll start from that value, we will go to the line of best fit, and then we'll continue to, in this case, the x-axis. Right, so let's look at how we go about doing that right now. Okay, so let us say this is my graph, right? And I have a graph. This is a graph that we have looked at in video 1. So we're just going to use this for the demonstration of this example here. So let us say I want to know what force or what would be the extension when a certain force is applied. So if I look, I have force on the y-axis and length on the x-axis. So if I want to know the length of the spring when a certain force is applied, let us say a force of 5 Newton. So I will start right here, I'll move over to the line of best fit, and then I will continue to, in this case, the x-axis. So let's look at how this is done now. So I start at 5, right, go over to the line of best fit, and then I will continue down to the x-axis, right? And from this, I'm seeing where when a force of 5 Newton is applied, the length of the spring will be 5 centimeters, right? And just as I mentioned before, it's just as though we can find a value on the x-axis that corresponds with a value on the y-axis, we can also find a value on the y-axis that corresponds with a value on the x-axis. So let us say I choose a value on the x-axis. In this case, I choose, let us say, 9 centimeters, and I want to know the force will give us a length of 9 centimeters. So I'll start out at 9 right here, and then I will go up to the graph. Right, I go up to the line of best fit, and then I'll go across to my y-axis, and I'm seeing where when the length of the spring is 9 centimeters, the force applied is also 9, in this case 9 newtons. Right, so let's talk about what else we can obtain from a graph. So we can also obtain what is called the gradient, or the slope of the line of best fit that is drawn on a graph. Right, now to find the gradient or slope, we will use the gradient formula, right? And that formula is given right here, where we say that m, right, is equal to y2 minus y1 divided by x2 minus x1, right? So this is our gradient formula, where we say that m, which represents our gradient, is equal to y2 minus y1 divided by x2 minus x1. Now, ensure that you pay attention to the denotation of these symbols, in this case, or y2, y1, and our x2, x1. Notice that the 2 is below, right? So therefore these are subscripts and not superscripts, right? So do not mistake this to be y squared or x squared, right? Now we're going to actually utilize this formula in future videos and actually see how we go about finding the gradient. But for now, this will be our formula which we will use to find the gradient of our line of best fit. Now, in the case of y2 and y1, x2 and x1, these are values on the y-axis and these are values on the x-axis. So we're going to look at how we go about finding values for y2, y1, x2 and x1. Okay, so let us say this is our graph again, which we'll be using as our example. So in order to find our y2 and our y1 values and x2 and x1 values, we will first need to identify 2 points on the line, right? So we're going to choose any 2 points on the line that are not in our table that we use to plot the points. So what we mean is that we're going to choose any 2 points along this line that are not any of these points right here, right? Because these points are the points that we obtained from the table. So we're going to choose any 2 points on the line, on this line here, to give us our values for y2, y1, x2 and x1. So the first point I'll choose is this point right here, and again this point is not in the table, so it is okay for me to use this point. So I'm going to choose a point right here, right? So what I'll do then now is, starting from the point, I'm going to go over to the y-axis so I can get the corresponding y value for this point right here, and I'm going to do the same thing for the x-axis, right? So here I can obtain the y value for this point and also the x value for this point on the line, right? And I'm also going to do that for another point that is far apart from this point. So let us say I choose this point right here, right? So I'm going to do the same thing, right? Go down to the x-axis so I can get my corresponding x value, and then I'll do the same thing so I can get my corresponding y value, right? So now I've chosen my 2 points, and again they're far apart, right? And they are not in the table, right? So these now will be my y2, y1 and x2 and x1 value. Now this point right here will give me my x1 and my y1 values, right? So here I'll get my x1 and y1 values, and right here I will get my y2 and my x2 values, right? So this is how we go about obtaining values for x1, y1 and x2 and y2, right? And again, we will use this information to find the gradient by using our gradient formula, right? So let's move on, right? So let's talk quickly now about trends and relationships in graphs. We're going to first discuss trends in graph. Now, we can say that a trend is merely an observable pattern in a set of results that is displayed on a graph. Now, when we plot a graph, we can observe an increase or we can observe a decrease in the set of data, right? So if we look at this graph here, we will see that there is an increase in the data, right? So both the data on the y-axis and the x-axis are increasing together. So this here will show an example of an increase in the trend in the data. Now, if we look at this one here now, we will see that there is a decrease. So as the quantity on the x-axis increases, the quantity on the y-axis is decreasing. So this shows us a decrease. Now, these two are what we can refer to as linear trends, right? And the reason why we say linear is because they are represented by a straight line. Now, sometimes we might not see a trend that is depicted by a straight line, right? So sometimes we might have something looking like this, right? And this is what we call an exponential growth, right? Now, if you are currently paying attention to the current coronavirus situation, you will see that across the world, the cases are increasing like this, where we have a rapid increase, and then we haven't reached that point as yet, but whenever we observe a trend that shows an exponential growth, there's usually a rapid increase, and then the increases start to slow down until we have some sort of a leveling off happening, right? And just as we can have an exponential growth, we can also have what is called an exponential decay. So we have a rapid decrease, and then that decrease starts to slow down, right? So those are the types of trends that we can observe. We can observe an increase or a decrease, and again, we can have it being a linear increase or a linear decrease, and an exponential increase and an exponential decrease. Now, let's talk about now the type of relationships that we can observe from a graph. Now, the first one we'll talk about is one called proportionality, right? And we'll actually look at a graph that shows a proportional relationship. So if we look at this graph here, right, we will say that this is a graph that shows proportionality. Now, a graph showing proportionality is a graph which has a positive sloping diagonal line just like this, right? So once you have a positive sloping diagonal line, it is referred to as a graph of proportionality, right? Now, the next relationship that we will look at is one that is called direct proportionality. So let's first look at the graph that shows direct proportionality, right? So this is a graph that shows direct proportionality. Now, we say that a graph that shows a direct proportional relationship shows a straight positive sloping diagonal line that passes through the origin, right? So just like the graph of proportionality, we obtain a straight diagonal positive sloping line, right? However, in the case of direct proportionality, it passes through the origin, right? Or it passes through the 0 point, right? So this line here, it's positive, it's diagonal, and it's sloping upwards, so it's positive, and it also points, and it also passes through the origin or the 0 point. Now, the next relationship that we look at is one referred to as inverse proportionality. Now, this is the graph that shows inverse proportionality, and we say that a graph that shows inverse proportionality is a graph that shows a straight negative sloping diagonal line, right? So this is our diagonal line, and in this case, it's sloping downward, so we're saying that it is negatively sloping, right? So let's just quickly wrap everything together that we have learned just far. So we have learned that we can obtain information from a graph by extrapolating or finding the gradient of the line of best fit, right? And to find the gradient, we will use a formula which says that m, which is our gradient, is equal to y2 minus y1 divided by x2 minus x1, right? And we can also observe trends and relationship between a set of data that is plotted on a graph. And the relationships that we can observe include proportionality, direct proportionality, and inverse proportionality. Okay, so again, this was Junior Roberts coming to you with realjuniorroberts.com. If there was anything in this video that you wish to get further clarification on, please post it below in comments, and I'll do my best to clear up any misconceptions for you. Like this video if it was helpful, and click the subscribe and the bell notification so you'll be updated whenever I post new videos like this. Share this so others can benefit, and thank you for watching.